So again, today we are graphing exponential decay. So say I have y equals 1/2 raised to the x minus 5 power. Okay? So I need to pick my x values, and I'm going to pick -2, -1, 0, 1, and 2. Okay? And let's find our y values. So I will plug those x values into the function. So here I have the function with all of the x values replaced. And so y to the 1/2, y equals 1/2 raised to the -2 minus 5. That is 1/2 raised to the -7. So as we know, a negative is going to flip the exponent. So that's going to be 2 to the 7th. Hey Siri, what's 2 to the 7th power? Which is 128. 1/2 raised to the -6th power is going to be 2 to the 6th, which is 64. 1/2 raised to the -5 is going to be 2 to the 5th power. And 2 to the 5th power is 32. All right, so we'll do 1/2, and 1 minus 5 is -4. So we flip that. That's 2 to the 4th. 2 to the 4th is 16. We have 1/2 to the -3. We flip it, and that's 2 to the 3rd, which is 8. Now, you're going to notice that all these y values, like 128, 64, 32, 16, and 8, are all off of our graph. So sometimes you need to plug in different x values than your normal x values. So what I'm going to do is I'm going to include 3, 4, 5, 6, and even 7. So I'll draw a line here. So I'm going to do y equals 1/2 raised to the 3 minus 5. Y equals 1/2 raised to the 4 minus 5. Y equals 1/2 raised to the 5 minus 5. Y equals 1/2 raised to the 6 minus 5. And y equals 1/2 raised to the 7 minus 5. So what that gives me is 1/2 raised to the -2nd, which is 4. 1/2 raised to the -1st, which is 2. 1/2 to the 0 power, which is 1. 1/2 to the 1st power, which is 1/2, and 1/2 squared, which is 1/2 of 1/2, which is 1/4. So I'll fill those in my table. So I have 4, 2, 1, 1/2, and 1/4. Now those are points I can graph on my coordinate plane. So I'm actually going to start with 2, 8, because I can actually graph that. So I'll say 2, 8 looks like this. So there will be 2, 8 up there. And then 3, 4, 4, 2, 5, 1, 6, 1/2. And I'll say that's 7. And I'll do 7 1/4. And then I will use a curve to connect our points. And I'll put arrows on the ends of my curve to show that it goes on forever. And that's how I graph y equals 1/2 raised to the x minus 5 power. You'll notice that our curve is always approaching the x-axis, but it will actually never cross the x-axis. So that is our horizontal asymptote. And that is where y is equal to 0. We also need to state our domain, which is what our x values can be. Well, our x values can be anything. So I'll say that my domain is all real numbers. My range, though, has to always be greater than 0 on the y-axis. So I will say that y has to always be greater than 0 because it has to always be above the x-axis. And that's how you state the domain and range, describe the horizontal asymptote, and graph y equals 1/2 raised to the x minus 5 power. Hope that helps.